right? 12 plus 3j. This will multiply with I2 because we are now writing the mesh equation for mesh 2. Okay. See, in between mesh 2 and mesh 3, that's mesh 2, and this is mesh 3. Mesh 3. In between mesh 2 and mesh 3, what do we have? Where is the common element? This is the common. This 2 minus j2. That is the common element, right? So what do we write? 2 minus j. There is a negative sign because I2 and I3 are flowing in opposite direction, multiplied by I3. What will be the right hand side? What will be the right hand side?
0.
No, you are writing mesh equation for mesh 2.
minus 5 angle 30.
Yes, right. Minus 5 angle 30. So if you obtain this value, you will see this is minus 4.33 plus 2.5j. You can do this 530. That means 5 cos 30. This will be your A. Okay, and 5 sin 30. This will be your B. Remember A plus JB. If you are converting from R angle theta, then R cos theta is A, R sin theta is B. So this will be your right hand side. Then you can obviously change this second equation by multiplying both sides by -1. You see, then you can get rid of this negative sign here. So it depends on you how you will choose to keep the equations. That depends on you. So this was the first equation. This is the second equation. For the third one, 5 plus 2, 7 minus 2j plus 10. So it is 17 minus 2j. That will be multiplied with I3. So write this in proper location. 17 minus 2j multiplied by I3. That's the self impedance term. Then two minus 2j, that is the mutual impedance between mesh 3 and mesh 2. You have to write this in proper location. Okay, 2 minus 2j into I. Then in between mesh 3 and mesh 1, minus 5, I1. This is equal to 0, however, because there is no driving force in the third mesh. So this is number 3. Now suppose if the question, according to the question, what do we require? I. See on your right hand side, I have written that Neymar's rule. According to that, how to find I2? Seven plus 3j minus j5 minus 5 minus j5 12 plus 3j 10 minus 2 minus 2j. So you can write this as in this way, minus 2 plus 2j. Then there is minus 5 minus 2 minus 2j. So you can write this as minus 2 plus 2j and 17 minus 2j. Right? As you are finding I2, so the second column that will be filled up by these values. Otherwise, 7 plus 3j will remain there. minus j5 will remain there, minus 5 will be there. Here also minus 5, minus 2 plus 2j will be there, 17 minus 2j will be there. But in the second column, that will be filled up by this value, 10 minus 4.33 plus 2.5 j 0. I am leaving this as a homework to you. You can try this, because if you go for the actual calculation of I2 here, then that will simply waste some time. It will take around say 5 minutes or 7 minutes to calculate everything, and then to convert it back into the polar form. So I am just giving it as a homework. You can try this. My intention is to make you understand that how to write the mesh equations using inspection method. Hopefully you have learned it. Hopefully. If you have not, if you still have any confusion or doubt, then you can tell me. I shall repeat this procedure. You definitely played with determinants matrix before. So that's why I hope you can definitely find I2. I'm just leaving this as a homework. So this is the method, inspection method, using which easily 3 different mesh equations can be written, and then using this Cramer's rule you can find any unknown variable. Okay. Now today we shall see another thing which is called super mesh. So let's see what super mesh is. Last day we were here. We were here. This is nothing but an application of mesh analysis, and I showed here that how writing the mesh equations is so easy once you learn the inspection method. Okay, someone has written something in chat. Is there no easier way to calculate current than by Cramer's rule? I don't think so. You can definitely subtract 2 equations or find one with respect to another. Then you can substitute. There are many methods. You have learned such methods in probably 7th or 11th standard. I mean 9th standard. Maybe lower than that. Anyway, how to solve equations, that's a well-known thing. There are 3 or 4 different methods available. But by far, Cramer's rule is probably the easiest. This matrix method. Also, there is a explicit mention of matrix method in your syllabus. So that's why I need to stress upon this thing. Okay, so I hope you understood this thing. I told you this last. Wait a minute. Yes. This is what we described last day. The above equations are basically the result of inspection method, and the lower format is given in matrix method. Once you have the equation, then you can definitely convert it to matrix format. There is no problem regarding this. You can find the solution also. Oh, by the way, you were asking about that. If you write that in matrix format, then if you know how to solve matrix, then there is another method. You have to take that inverse of matrix and all. You know how to do this. That is also actually derived from the Cramer's rule. Nothing extraordinary. Anyway, so now the today's topic, super mesh. I have taken snapshot from a book. See here the concept is written, concept of supermesh. What is this? Supermesh can be described in two different ways. There are two special cases of mesh analysis where sometimes we feel we actually don't calculate directly the voltage, because normally what we do when we see that the current is flowing through a circuit element or an impedance, then we multiply the current with the impedance to find the voltage value. But sometimes it may happen that in a certain branch we have a current source. Then what exactly the voltage is across that current source we never know, because our simple analysis of Ohm's law tells there a branch contains a current source, there is no impedance. So how will you multiply and what you will be multiplying with? There is a current value, of course, but there is no impedance. Then how will you find the voltage? So in these cases, there are two special cases where we use the concept of supermesh. So see the first one, case 1. Let me tell you that supermesh is formed. How do we form the supermesh? This concept is used when a circuit contains current sources, as I mentioned. A supermesh is formed by excluding the branch containing a dependent or independent current source connected in common to two meshes and any other elements connected in series with. That means if a branch contains a current source or a branch that contains current source along with some series circuit element, it may be resistor, inductor, capacitor, whatever. In that case, that particular branch is excluded during analysis, and excluding that branch, what we form is called supermesh. When I shall illustrate this method, you will get to know that how supermesh is formed and how supermesh equations can be written. Okay, as I mentioned earlier that this concept is necessary for loop analysis with current source, because the voltage drop across the current source is unknown. What I was saying, that if you suddenly have a current source like this, there is no impedance here. So how will you find that what you need to multiply with? Right. So that's why this, due to this kind of problem, we have a different method. Okay.
সুপারমেশ আরেকবার বলবেন?
Supermesh is written, see.
কিন্তু বুঝতে পারছি না, একটু প্রবলেম হচ্ছে। সুপারমেশটা মানে কি বলছে, কি করে বোঝা যাচ্ছে সার্কিটটাতে?
Okay, I shall explain supermesh for two different cases, then you will definitely understand. Just wait a minute. For the time being, just know this, that supermesh is applicable when a circuit contains a branch where we have a current source, or if the branch contains a current source along with some series circuit element. Then what we do, we exclude that branch to form the supermesh. However, there are two cases. So let's see what is the first case suggesting. This is the first case. When a current source is in one mesh. When the current source is in one mesh. See this figure, figure A. There are two meshes, this one and this one. There is a current source here. See, there are two meshes, but only one mesh contains the current source. Sometimes we describe this situation saying that current source lies at the perimeter. current source lies at the perimeter. As you can see here, this current source lies at the perimeter of the circuit. Under this case, what this method suggests, that in this case, the mesh current is taken equal to the current of the current source, which means if there are two meshes, this is mesh 1, this is mesh 2, then mesh 2 currents, that is I2, this is taken exactly equal to the current delivered by the current. Obviously, you need to identify the direction. Accordingly, you should choose the value. I mean, value wise, there, see what it has been suggested. According to case 1, when a current source is in one mesh, or you can say when a current source lies at the perimeter of the circuit. In this case, different circuit configuration will have different type of circuit. You have to identify whether there is a current source lying at the perimeter. I shall show you other examples also. So here you see, here you don't need to solve for this current, because whenever there is a current in a branch, that branch current is exactly given by the current source itself. What is the utility of mesh method? If I ask you, then actually what we do using mesh method? We solve for mesh currents, right? We denote currents like I1, I2, I3, etc. And then finally we solve for them. So here, though there are two meshes, I1 and I2, but and obviously there are two unknown variables, I1 and I2. But here actually we need to solve for only I1, because I2 is already known according to case 1. When a current source lies at the perimeter or a current source is in one mesh, then that mesh current is entirely determined by the current source. Am I clear? So I2 here, I2 here is taken as minus 10. Why minus? It's very clear from the picture. You can see that the chosen direction of I2 is anti-clockwise, I mean clockwise. However, the shown direction of IS is anti-clockwise. So that's why I2 is minus 10. However, the value is same. Now come to case 1, I mean case 2. This is somewhat difficult. Case 2. What does case 2 say? Case 2 is actually moving into the deeper of this in the deep of this concept, that what Supermesh was saying. When a current source is connected between two meshes, then when a current source is connected between two meshes, then how will you solve the circuit? This picture is not present in this slide. I shall show you a different slide, but just go through what has been written. As I was saying, that if a branch contains a current source and a series circuit element along with it, this is applicable for case 2, when a current source is connected between two meshes. In this case, a super mesh is considered excluding the branch with the current source and any elements connected in series with it. Okay, first digest this thing. Okay, then I shall go to the next point. First, try to understand what this is saying. Wherever you find a branch containing either a single current source or a branch which contains a current source along with some series circuit element, and that branch is shared by two adjacent meshes. As you can see in this case 2, when a current source is connected between two meshes, that means the same. When two adjacent meshes share a current source or some branch like that, then you have to exclude that branch. Exclude means you cannot simply remove it, you cannot simply withdraw it and throw it somewhere. No, that is present actually, but we are virtually assuming that that branch is absent. Exclusion means that. Then what does it say? Both KCL and KVL is written for the super mesh. So an example is given now. Now try to understand what is happening. Suppose I name this nodes as A, this is B, this is C. This is actually not a node. Let's say this is D. These two are the same node. This is suppose E. You see A, B, C, D. This is given as X. Anyway, consider this as D. A, B, C, D, A. This is a mesh. This is a mesh. B, E, C, B. This is also a mesh. D, E, D, C. This is a mesh. Now see, in between these three, only this one does not contain, sorry, not that, only this one, DECB, this, the second one, that does not contain any current. Right, so you can write the mesh equation for this mesh easily. But here you can see in between points C and D, there is a current source. Current source and a branch that contains a current source with a series circuit element. So that actually satisfies this condition, case 2. When a current source is connected between two meshes, you can see this A, B, C, D, A and C, E, D, C. These two are the meshes which share this current source. So if you exclude this branch, this line, this oval shaped line that is shown here to exclude that branch. This is excluded, and what we get is the super mesh. So what is super mesh? That super mesh is A, B, C, E, D, A. This entire thing A, B, C, E, D, A. This is now our super mesh after excluding this branch. Okay.
স্যার এটাকে কেন কেন এক্সক্লুড করছি বলবেন একবার?
একবার রিপিট করুন স্যার।
কেন
definitely okay. That's what the method is saying, that when a current source is connected between two meshes, then a super mesh is considered excluding the branch with the current source and any elements connected in series with it. Okay. Now you are asking why we are excluding this. See, actually you can find the voltage across this because you know the current. You can find the voltage across this, but can you find the voltage across this current source? Do you know what exactly the voltage across this current source? No. So obviously you need some method so that we can overcome this problem. The super mesh is basically that. We are first excluding that, and then we shall again take into account using this. See, the second line says both KCL and KVL is written. You shall see that this is basically, this is actually the KCL. This is called constraint equation. I shall come to this point later, but first tell me whether you have understood that if we exclude that branch, then how do we form the super mesh? Have you understood this or not?
Yes, sir.
Okay.
Yes,
So
স্যার তাহলে ওই
KVL,
I2 এর পার্ট
yes,
স্যার
yes.
স্যার তাহলে I2 যে ডেটা আছে ওইটা কোথায় যাচ্ছে?
কোনটা?
ওই যে I2 এর পার্টটা মানে যে লুপে
Okay,
I2
see,
হচ্ছে
yes, you are saying about the second mesh, BECB, that does not contain any current source. So that's a simple mesh. It is not a super mesh.
ও
See,
আচ্ছা স্যার
KVL for the second mesh, this is simply written as it is. What you have already learned. See, though it has taken the straightforward way 2I2 plus 4 into I2 minus I3, then you have to rearrange the terms, but you know the inspection method, 2 plus 2, 4 plus 4, 8. So it is 8I2. Then you see that the direction of currents are different through 2 ohms, so minus 2I1. And here also minus 4I3, that is equal to 0. The exactly same equation you will get from this. See? Minus 2I1, 2 and 4, that is 6 plus 2, 8, and then minus 4I. Same equation. That does not contain, actually the condition demands that there should be a common current source between two adjacent meshes. Then only you can exclude the branch and you can form the super. As you can see, there are 3 meshes in the circuit. That's why I have written the node names. A, B, C, D, A, that's a mesh. C, E, D, C, that is another mesh. These two adjacent meshes contain a common current source, a branch that contains a current source. So that's why I have excluded this according to the method, according to the rule. Then we form the super mesh. Now we have to understand, now while writing the KVL for super mesh, we have to see exactly which current is flowing through which circuit. Say 2 ohm. Through 2 ohm, which currents are flowing? There is I1, there is I2. So that's why 2 multiplied by I1 minus I2. Then see this 4 ohm. Through this 4 ohm, which currents are actually flowing? I2 and I3. So remember I said once that actually it is the virtual exclusion. We are not exactly, I mean, in reality the branch stays there. It is just a method. So that does not mean that you are withdrawing this branch and I1 will suddenly leak into this mesh. No, not that. So see that which branch is there. I mean, which branch currents are there. Through 4 ohm, which currents are flowing? I2 and I3. So 4 into I3 minus I2. This is your super mesh, okay? This part is your super mesh. So in this super mesh, just see how many impedances are there and which current is flowing to which impedance. Then see through this 8 ohm, only I3 is flowing, so 8 into I3. And in this entire super mesh, the driving source is 6 volt. So that is the super mesh equation, number 1. This number is important because remember, actually we had 3 meshes. So there will be at least 3 equations to solve it. That's the first equation. The second equation is, now if you consider that excluded branch, see what is happening actually in this branch. What is happening in this branch? There is I1, I1 is flowing downwards, and there is I3, I3 is flowing upwards. Whenever a branch contains a current source, remember that branch current is actually given by that current source, 3 ampere. But although we can see from the given circuit, I1 and I3, they are also flowing. So there must be a relationship between these currents, I1, I3 and this 3 ampere. What do you think? What is that relation? I1 is flowing downwards, I3 is flowing upwards, but the net current 3 ampere that is shown to be flowing downward. So definitely then I1 is greater than I3. So I1 minus I3 equals to 3 ampere. Is that understood?
Yes.
Yes, sir.
Yes, sir.
That's basically a KCL. See, that has been written there, right? Applying KCL at any one node of the omitted branch, you can think in this way: a constant equation. Just see the value of the current source 3 ampere, then see how many currents are flowing through that branch. As we can spot, I1 is flowing downwards, I3 is flowing upwards, but the net current that is shown downwards. Let me show you in this way. This is suppose I1. This is suppose I3. So if I1 is greater than I3, then the resultant will flow downwards. If I3 is greater than I1, then the resultant would have flown upwards. But here the downward current has been shown. I1 minus I3, that is equal to 3. That's our second equation, what we call constraint. And for the third mesh, which is not a super mesh, this one for 2, you can definitely write this: minus 2I1 plus 8I2 minus 4I3. That's our third equation. So we get the equations, solve them, you will be getting the solution. That is the method. Now obviously, just observing this one example, you can fathom actually that what super mesh is. So for that we require some more example, and then let's see whether you can understand that or not.
Hello, sir.
Yes,
I1 minus I3
স্যার ওই যে 3 অ্যাম্পিয়ারের নিচে যে 1 ওহমটা আছে রেজিস্টার, ওইটা কোথায় যাচ্ছে?
does not matter. If a branch contains a current source or a series circuit element, whatever this is, if it is shown as 1 ampere, even if it is an inductor, capacitor, whatever, this branch will always contain a current which is given by this current source. So it doesn't matter what is connected in series.
ওকে স্যার।
That is the trick actually, because if you consider that 1 ohm, then you have to find potential drop across 1 ohm separately. You have to assume a voltage across this current source. Then you have to write KL. So that's a lengthy process. That's why this is a trick of government.
ওকে স্যার, আন্ডারস্টুড।
Okay, let's see this one. Actually, the solve is given here. Just try to understand what they have done. I have taken this from a book. I shall explain everything here. Try to understand what is happening. How many meshes are there? First question. How many meshes are there?
Sir, 4.
4 meshes. So, is there any super mesh? Yes.
Yes,
One super
sir.
mesh.
Yes,
Which
sir.
case of super mesh is applicable here?
So middle one.
Which
রিমুভিং দ্য
case?
মিডল পার্ট।
Which case of super mesh is applicable here? There are 2 cases.
সেকেন্ড ওয়ান।
Case
No.
2. Case.
Both. See the circuit. See, there is a current source which lies at the perimeter here. This is suppose I1. This is suppose I2. Let's say this is I3, and this is I4. Let's assume. I mean, according to this should be I2 anyway. So let's denote the current in this way. meshes 3 and 4 form a super mesh. So that means they have chosen this loop as first loop, I1, this as I1, this as I2, and this is as I3, and this as I4. Now check. The second mesh that contains a current source at the perimeter, I am writing. The second mesh contains a current source at the perimeter. So that satisfies the condition of case 1. Remember, case 1. Okay. So immediately what you can conclude here, when a current source lies at the perimeter, then that mesh current will be given by that current source.
I2 equal to that one. Yes, sir. Yes.
Yes, I2 equals to that one, but their directions are different, so that's why
Minus essentially.
minus. I2 equals to minus. That is one equation. Then see, there is one particular mesh which is not a super mesh. Which one? Mesh 1. This one. This is not a super mesh. So for that you can definitely write the mesh equation. What is that mesh equation? For this 8 minus 2j multiplied by I1, then minus 2j multiplied by I2 with a negative sign. Other things. Okay, I shall write that equation later. Let's see mesh 3 and mesh 4. Mesh 3. Mesh 3 is denoted by current I3. Mesh 4 is denoted by current I2. Mesh 3 and 4. See, in between these two, we have a current source. We have a branch that contains a current source. I hope you can see that. There is a branch that is shared by two adjacent meshes. So that is now satisfying the condition of case 2. It says that if a current source is shared by two adjacent meshes, then we exclude that branch. So if we exclude this branch, then what do we have? We have this minus J4. So where is our super mesh? The super mesh is this. This portion is our super mesh. Now which current is flowing through what? Through minus J4, IT is flowing. Through 6, I4 is flowing. Through 8 ohm, I3 minus I1 is flowing. So let's write mesh 3 and 4 form super mesh. So the super mesh equation, what will be that? Let's start with this 8. 8 multiplied by what? I3 minus I1. Then 2 minus J4, only I3 is flowing. Through this 6 ohm, only I4 is flowing. And through this J5, I4 minus I2 is flowing. And this in this entire super mesh, there is no voltage source. So the right hand side will be 0. So that's our number 2 equation. This was number 1. There should be a constant equation. What is the constant? Tell me now. What is the constant equation here?
I1 এর
I3
ইকুয়েশনটা
Yes, I3 is flowing downward.
I3 minus I4 equal to 4.
No, I4 minus I3 rather. See,
Oh, ha.
Yes, sir. I4 minus I3.
I4 minus I3. See, I4 is flowing upward. I3 is flowing downwards, but the net current is shown upward. So the constant equation is I4 minus I3 is equal to 4. This one. I4 equals to I3 plus 4, the same thing. So how many equations we got? That was the first one. That's the second one for super mesh. Constant equation is the third one. And for the first mesh, which is not a super mesh, for that you can write in this way, or you can simply use that inspection method 8 minus J2, that will be multiplied with I1, then minus J2 multiplied by I2 with a negative sign, so 2J I2, then minus 8 multiplied by I3, and that is equal to 10. That's our fourth equation. So let's see them here. That's your super mesh. See what we got from the super mesh. From this 8 minus J4 into I3 for the super mesh, minus 8 I1, 6 plus J5 into I4, and minus J5 by 2. Everything is correct. Constant equation that we found, that is also correct. This is the equation for the mesh which is not a super mesh, that found using inspection method. So finally what we got is this. And then probably the question was solve for V0. Solve for V0, this voltage. So to obtain V0, you require both I1 and I2. So that has been solved here. I shall provide this PPT. You can check this. Though it has been taken from a standard book, so it is obvious that the answer is correct. You just need to understand the method. See, here finally I1 has been obtained. I2 is already known. If you remember, I2 is already known. So V0 has been obtained in this way. V0, if you see this voltage that is across the capacitor. So I1 minus I2, that multiplied by minus J2. That should be the voltage, right? This has been taken from Sadiq. Sadiq's book is available in internet. You can download it and can see there. But the thing is whether you have understood this concept or not. This is the main point. If you have understood the concept, then you can definitely apply it everywhere. Let's watch one more. Check this. Check this. That's an example of super mesh again. See what is happening. The question is determine the current in 5 ohm resistor. 5 ohm resistor is here. Which case of super mesh is applicable here? Can you tell me?
The first one.
No,
Sir, case 2.
Oh, no, sorry, second one.
Case 2 হচ্ছে, case 2 হচ্ছে, middle এ আছে।
second one. So how to apply this? Just see what is written, then everything will be clear. First of all, tell me how many meshes are there?
3.
Three?
Three.
Sir, 3.
Three. Yes, three. Three meshes are, I'm writing, okay. Three meshes are A, C, D, A. This is, then there is A, B, C, A. Then there is C, B, D, C. If you observe carefully, then ACDA, that is not a super mesh. ACDA, this one, this is not a super mesh, right? But ABCA, this, and CBDC, this, ABCA and CBDC, they contain a current source, a branch that contains a current source, or any other series circuit element is also applicable, is also permitted to stay. Yes, so if you exclude this branch, then what we get is a super mesh. But actually that branch stays there in reality. This is just a virtual exclusion. Actually the branch stays there. So while forming the super mesh, you have to assume that as if this branch is absent. So now what we get is a super mesh which is A, B, C, C, A, right? That's the super mesh. See, it has been written here, super mesh A, B, D, C, A. So what will be the super mesh equation then? See, through 10 ohm, which currents are flowing?
I2 and I1.
What is
I1
the
and
effective
I2.
current? I2 minus I1?
I2 minus
Yes, sir.
I1.
Why not I1 minus I2? Can you tell me? Because you are writing the equation for the right hand side, that means for the super mesh. And when you are writing a mesh equation, the mesh current will get the highest priority. That is assumed to be greater than other current. That's why it is I2 minus I1, not I1 minus I2. So see, 10 into I2 minus I1, that's the first term. Through 2 ohm. Through that 2 ohm, only I2 is flowing, so 2 into I2. Through that 1 ohm, only I3 is flowing, so 1 into I3, that's simply I3. And through that 5 ohm, there is the current
I3 minus I1.
I3 minus I1. So 5 into I3 minus I1, that is equal to 0. So that is our super mesh. Super mesh A, B, C, D, A. 10 into I2 minus I1, 2 into I2, I3, 5 into I3 minus I1 equals to 0. That's our super mesh equation. Then, just like super mesh, as you know, if you draw your ear, then obviously your head will also go into that way. So just like super mesh, equation is bound to come. What is that constant equation? Now, if you consider that branch, see, actually, what is the current value? 2. And this 2 ampere is contributed by which two currents? I2 and I3. I2 is flowing from B to C. No problem. I2 is flowing from B to C. I3, on the other hand, is flowing in opposite direction, C to B. But the net current that is flowing in which direction? B to C. So obviously I2 must be greater than I3. So that's why constant equation is this. I2 minus I3 equals to 2. Okay. And mesh 1, which is not super mesh, you can definitely write the mesh equation. What is that? By injection, 10 plus 5, 15 self impedance multiplied by I1 minus 10 I2 coupling impedance or mutual impedance minus 5 I3 equals to 50. That's your third equation. Simple, isn't it? So determine the current in 5 ohm resistor means what? You need these two currents. 2 5 ohm, I1 and I3, these are doing. So I1 minus I3, this is what you need. So you have to solve for this I1 and I3. How do we find it? This is how we find I1. These are the equations. If there is no I1, then write 0 into I1 there. So what are the coefficients? 0, 15, 10. 0, 15, not 10, rather this one. This is the equation. Minus 50. Then 1, minus 10, 12. 1 minus 10, 12. Are you getting this? The constant equation is I2 minus I3. So you can write this as 0 into I1 plus I2 plus I3 equals to 2, right? So if you consider this as 1, this equation as 2, and this equation as the third equation. Then using Cramer's law, any current can be found, I1, I2, I3, whatever. So if you are finding I1, then the denominator determinant will contain all of them. Which one? This 0, then 1, then minus 1, 0, 1, minus 1. Then what do we have? 15 minus 10 minus 5, 15 minus 10 minus 5. Then what do we have? Minus 15 plus 12, 6. Minus 15 plus 12, 6. And as you are finding I1, so the first column will be replaced by 2, 50, 0. 2, 50, 0. Otherwise, the rest of the columns will remain the same. Find I1. Similarly, you can find I3 also. See, this has been shown here. So after that, I5 can be obtained by just substituting that I1 minus I3. And the
Hello,
final
sir.
answer is this, 4.66 ampere. Understood?
Hello,
Is that
sir.
clear? Now tell me if you have any question.
হ্যাঁ স্যার, এইটা আমি সাইমালটেনিয়াস দিয়ে করলাম। আমার এই I1 আর I3 এর ভ্যালু গুলো আলাদা আসছে, কিন্তু I5 ওম এর আনসার সেম আসছে।
I5,
I5 ওমটা ঠিক আসছে, কিন্তু I1 আর I3 এর ভ্যালু আলাদা আসছে।
how is that possible? Anyway,
আমার
final
আমার
answer is correct.
I1 এসছে 18.67 আর I2 এসছে 14। I3
Possible. Check. Others also check. See. Yes, what you are saying,
18.67 আর 14।
14, acha, 14
0.
ampere. Okay. So those who have not done it, check whether he is correct or not. Final answer is this, 4.6. It's 2:41, so I need to leave now. Otherwise, I had another question. Or actually, two more questions. Anyway,
তো পরের দিন হয়ে যাবে।
oh, definitely. পরের দিনই হবে. In the meantime, you try to do this and try to understand what I said. If there is any doubt, tell me. Otherwise, I shall call the rule. You can take a screenshot of these two questions and try this at home. That's a university question, this one. I had an intention of solving this here, but I didn't get time. You can take a screenshot of this page and try this at home. Also this. which involves super mesh as well as dependent source.
স্যার আগেরটা আরেকবার দেখাবেন?
একটা এটা and this one.
ওকে স্যার।
Okay, rule number 1. Two.
Present, sir.
Sir, roll number 62 present, sir.
Hey, sorry, 62. Oh, sorry, এটা তো EC2.
Yes, sir.
Sorry. তিনটে branch. 62.
Yes, sir.
63.
Present, sir.
64.
Yes, sir.
65.
Yes, sir.
66.
Yes, sir.
7.
Yes, sir.
8.
Present, sir.
9.
Yes, sir.
70. 70. 70 is present. I see. 71. 71. 72.
স্যার ও নেই।
Present, sir.
72 present.
17 present. 72.
Okay, 73.
Yes, sir.
74. 74.